Aluminum versus copper wiring. Comparing aluminum and copper wiring is common in electrical design. Copper usually comes out on top. Why? Let's explore. Disadvantages of aluminum wiring. Aluminum is less expensive, lighter, and more malleable than copper. However, it has significant disadvantages. The major danger of aluminum wiring is the risk of fire hazards. Aluminum has about 40% less current capacity than copper, because of its higher resistance to current flow. As a result, it generates a significant heat when conducting electricity. Adding to this potential fire hazard is copper's high thermal expansion. Over time, these expansion and contraction cycles can loosen connections at terminals, thereby increasing fire risk from arcing. Aluminum also passivates to form an anti-corrosive oxide layer. However, this layer is strongly insulative to current flow, further reducing conductivity. This necessitates occasional application of anti-oxidation compound at its terminals. Also, aluminum readily reacts with water at room temperature, forming aluminum hydroxide alongside hydrogen deposits. This puts it at risk of dissolution when used in underground applications, especially in areas that experience flooding and earthquakes. Another issue with aluminum wiring is that voltage drops become significant for longer runs. So, there is often a need to increase the size of the wire to compensate for these losses. Benefits of copper wiring. Currently, copper provides the dominant material for making power cables. However, prior to the 1960s, its popularity waned as aluminum wiring gained prominence in American homes. But by the 1990s, copper retook its place as the preferred option. Copper is an excellent conductor of electricity. As a result, the diameter of copper wiring can be much smaller than aluminum, but still carry more current. This enables it to transmit more power without overheating, thus minimizing the risk of fires. Also, the use of smaller cables allows multiple conductors to share the same raceways, which creates an avenue for cost savings. In addition, copper has low thermal expansion, meaning that terminals remain secure despite several contraction and expansion cycles. Copper has up to 40% more tensile strength than aluminum. Therefore, it can undergo extreme stress during installation and operation with minimal risk of wear and tear. This allows the use of thinner diameter wires without breakage issues. When copper oxidizes, it remains a great conductor. As a result, it can last long despite tough conditions. Because of this robustness, it is ideal for underground applications where it is not susceptible to dissolution. Differences between aluminum and copper wiring. Cost. Aluminum offers cheaper production costs. Moreover, copper it is more scarce and subsequently more expensive. In addition, copper's rigidity means it requires greater manufacturing time. As a result, cost savings when using aluminum over copper can be up to 50%. Durability. The use of aluminum wiring results in higher maintenance costs than copper. First, aluminum's significant contraction and expansion cycles requires regular inspection of terminals. Also, its exposed parts need periodic cleaning and the application of anti-oxidation compound. Maintenance. Aluminum oxidizes to form an insulative material that further restricts the flow of electricity, while that of copper remains conductive. Because of oxidation, the lifespan of aluminum wiring is usually around 80 years, while that of copper can exceed 100 years. Weight. Copper weighs roughly 70% more than aluminum. As such, when installing large amounts, it becomes difficult to handle. Conductivity. Copper is a better conductor of heat and electricity than aluminum. Thus, it is less likely to overheat. Moreover, aluminum wires require a 56% larger cross-sectional area than copper to carry the same current.